Hi, hopefully you've watched the first recording that I sent. If you did, in that recording, we were kind of typing manually on the calculator to program and then making that program that was doing the surface area of a cylinder. We're going to do a program here that's going to be a little bit different. Um, you probably realize that typing on the calculator is kind of a big pain in the butt, but there is a better way to do it. I had you download some software kind of going into today's class, or I guess into this video recording. And that software will actually allow us to write code on our computer, which is going to be a lot better. This video will require you to be able to plug your calculator into your computer. You can do all of it without doing that, but you won't actually be able to run and test any of your code. So if you don't have that ability, just follow along and kind of type the code in TI Connect with me. If you do, kind of when I'm plugging in my calculator and uploading my code, you should kind of be doing the same with yours. Um, for me, I have kind of regular TI-84 calculator. Yours probably came with a charging cable that looks something like this, kind of has a USB on one end and then this end plugs into the calculator. I don't actually have a USB port on my computer, so I need an extra dongle that allows me to connect to USB-C. So if you don't have this, you probably won't be able to actually plug in your calculator today while you're watching this video. That's fine. Just kind of listen in and hopefully kind of absorb the concepts as you're going through. And then why don't you plan on kind of shooting me an email and meeting up with me before next class so we can make sure your code works. I'm going to share my screen now, and we can get started kind of going through the code. So this is what TI Connect looks like when you open it up. To create a new program, you click this kind of button with the three boxes and it'll open up this kind of overall menu. You'll notice that over here, there's kind of a bunch of drop downs. And if I actually look at this, these are a lot of the buttons that are on my calculator. We can look at it more specifically when we actually start using stuff. So I'm going to click New Program. And you can see now I can kind of open up those drop downs, and these are all things that you can kind of do on your calculator. We're going to use the keypad menu a lot. Sometimes we'll use some stuff in the math menu, and we're going to use stuff in the program menu a lot. This is where we kind of grabbed the prompt and disp commands that we used in the last program. We're going to use those again here. Let's go ahead and call this program 2 points, just like that. And what this program is meant to do is, let's say I give you 2 points. Let's say I give you the points, so I'm trying to draw my screen on a trackpad. 1, comma 2, and 4, comma -3. The goal of this program is to find the equation of the line that passes through those 2 points. So pause me for a second and kind of think about, like, mathematically, what do you actually need to do that? And if you're unpausing me, you should have kind of said that we need both a slope and a y-intercept. We're going to be doing this in slope-intercept form. So eventually we want a line that looks like kind of our regular y equals mx plus b form. So to do that, how do we actually find the slope? Well, there's a formula for that, right? Isn't it y2 minus y1 over x2 minus x? And this is going to be our slope m. So I'm going to do a little arrow and pointing to m. And then how do we actually find the y-intercept after that? Again, pause me for a second and kind of think about algebraically, how could we do that? And if you're unpausing me, eventually we're going to have a line that kind of looks like y equals mx plus I. And I'm using I because when we pass in our 2 points, we're actually going to pass them in as 1 point A, B, and 1 point C, D. Oh gosh, that's so bad. Where's my undo? There we go. And 1 point CD, like that. So we're already going to be using the B variable, so we're going to use I for intercept. So let's say if I want to solve for this, can't I just algebraically isolate for it in this equation? If I subtract this mx term to the other side, I have I equals y minus mx. Now we don't have x and y variables, but I do have two xy points that I can use here. So I can plug in actually either of them. And let's just use A and B. So I'm going to say I equals the y coordinate is b minus m times a. And I'm putting the multiplication symbol there very explicitly because you can't just say MA. Your calculator won't be able to read what's called implicit multiplication. You have to actually put the symbol. So this is kind of what we're trying to do. We're going to find this M, we're going to find this I, and then we're going to try to display something on my screen that looks like that. So I'm going to try to leave this on the screen. It might kind of cover some of the stuff I'm doing, so I might eventually erase a little bit of it. But for now, think our first line of our kind of sassy Lind program, didn't we have to kind of prompt for values? We need 4 values for this program, right? Because we need 2 x coordinates and 2 y coordinates. So I'm going to go in the program menu. Let's go to input output, and I'm going to click prompt to put it on the screen. Now, you can find all of these commands in the menus. You can actually also type them, but be careful when you're typing, it does have to be exactly kind of as this looks. I'm prompting for A, B, C, and D, and it kind of just fits. Once I have A, B, C, and D, I need to solve for these 2 values. We solved for the slope in kind of the form with the formula that we're used to over here. But let me actually erase this. Let's do this in terms of A, B, C, and D, since that's how we're going to need to do it in the program. So if you remember, it was y2, which is D, minus y1, which is B, over x2, which is C, minus x1, which is A. So when I put this in my program, I'm going to do something wrong here and kind of think about why it's wrong as I'm typing. I'm going to do D minus B divided by C minus A. And if you're thinking right now, you're missing the parentheses, that's kind of the the right wrong thing. I do need parentheses here just because whenever I'm coding, it does actually obey order of operations. And it would have done kind of B divided by C first. And what I want to do is I want to store that in the variable M. So store, if you remember, was a button on your calculator. In the keypad menu, it's this little arrow here. So I'm going to store that in M. Then I'm going to do a very similar thing for I. Now that I have M, I can say B minus M times A, and I can store that in I. And then this last line that we're about to do is going to be a little gross. We need a kind of long display command. And in the last video, we talked about kind of the difference between when we want to put things in quotations in a display command and when we don't. Let's think about what we want in quotations here, right? So this is the formula here that we're trying to kind of get on the screen. Think about which parts of these you want to actually be numbers that are shown on the screen and which parts are actually symbols. I think I want a number for M, and I think I want a number for I. So when I type M and I in this display command, they're actually not going to go in quotations. So let's do, and this time I'll type it just to show you, right? Disp command, if you wanted to pull it in from here, is kind of in the program input output. It's right here, but I'll type it. So disp y equals, I do want to show up as kind of the letter Y in the equal symbol. M, I want the number. X plus, I want the symbols. And I want the number. Great. So now what I'm going to do is I'm actually going to take my calculator. I'm going to turn it on. And then I'm going to plug it into my computer. Ooh, there we go. To upload something onto your calculator, to upload a program from TI Connect, you press this button. That kind of looks like an arrow going into a calculator. So I can press this, and it should kind of pop up with this here that recognizes that my calculator is connected, and I can click send. And I'm going to stop sharing for just a second so that I'm kind of full screen, and hopefully you'll be able to see this a little bit. I guess I should really unmirror my video. Let's see if I can figure that out. It's been a while since I've done Zoom. There we go. Oh God, it's weird to look at now. All right, so the way that you run this is you actually press the button that says PRGM here. And you can see there's now a new program in my calculator called 2PWTS. I'm going to hit the enter button down here. And it will kind of prompt it on my screen. I can hit enter again. This is just like what we did for Sassyland. And then I'm going to put in 2 points. Let's do 3, 5, 6, and I'm going to do -9 for the last one. When you're doing negatives, remember it's this button down here. And you'll see if I hit enter, it should print out a line. Uh, so it seems like this is working pretty well. But let me try another line. I'm going to run it again. So I'm going to go program, and then it's on 2 points. I'm going to hit enter. I'm going to hit enter one more time. And what I'm going to type in is going to be 2, 7, 2, and -13. I'll hit enter. And this happens. I'm getting an error that says divide by 0. So let's think about what's actually happening here. I'm going to share my screen again just so I can draw on it. And let's talk about what's going on. First, let's think about what this line actually looks like. I've got 2, 7, and 2, -13 as my points. Let's draw a little kind of graph here. Oh God, you're late for class. All right, 1, 2, let's say 2, 7 is kind of somewhere, let's put that here, right? Then wouldn't 2, -13 be kind of somewhere down here? And if I actually draw the line that connects these 2 points, isn't that a vertical line? What is the slope of a vertical line? If you said undefined, you're correct. Vertical lines actually don't have a real number slope. And this is why. If you remember, when I was finding the slope, wasn't I doing D minus B over C minus A? And that was going in M. If we plug this in for our points, we've got -13 minus 7 over 2 minus 2. Which what's happening here is I'm actually dividing by 0, which my calculator actually won't let me do. So there's actually kind of a bigger thing going on here. I actually want to do different things in my code depending on if I'm about to get a vertical line or not. If I'm about to get a vertical line, I don't want this line to happen the way that it is because it's actually going to give me an error. So I need actually some way to check that I'm going to get a vertical line. I'm going to clear everything on the screen. And let's actually change our code a little bit. I'm going to introduce a new command to you before that you've probably never seen, and that's called if. If allows me to kind of split between different cases. In some cases, I might want to do one thing in my code, and in other cases, I might want to do another thing. In this particular situation, I kind of want to do one thing when I have a vertical line and one other thing when I don't. This is what I want to do when I don't have a vertical line. How do I check if I have a vertical line? Well, the issue was that I'm getting 0 on my denominator, specifically because C and A were the same value. So there's a couple ways you can do this. I could type if C equals A. I could type if C minus A equals 0, which I think kind of makes a little more intuitive sense. So let's do it like that. And notice I just typed this, no spaces. How TI Basic works as a language is after every if, you need a then, and then just goes on its own line. So if C minus A equals 0, we're in the case where we have a vertical line. And unfortunately, I already erased my vertical line that I drew here, but it looks something like this, right? 1, 2, and then my line was kind of here. What actually was the equation of this line? You said x equals 2. You're right. And remember, we ran this with 2, 7, 2, -13. So this 2 is actually coming from both of the x coordinates of my points. So what I want to do if I have a vertical line is let's disk x equals, and then I can use either one of my x coordinates. So let's just do C. So this will now work correctly for the case where I have a vertical line. But I need a way to tell my code that I only want this to happen kind of in the other case. And I have a completely new command to show you, which is something called an else. Not every if has to have an else, but an else is kind of part of what we'll call an if statement. When I add an else, it means that I'm splitting off into two distinct cases. If the condition that I wrote here is true, so if C minus A equals 0, which is another way of saying if I have a vertical line, then I'm going to display this. If I'm not in this case, if this is not true, then I'm going to do the rest of this. So this code only happens if this part here is not true. Just another TI basic thing. Every time you write an if statement, it always ends with the word end. And now if we run this, this should fix our problem of getting that error. So I'm going to, again, re-upload this to my calculator. Let's get rid of my drawings again on the screen. Let's re-upload this. I'll stop sharing just for a second so that I can show you what's kind of happening on my calculator. Let's go ahead and rerun this. So I'm going to go program and I'm going to hit enter. I'm going to hit enter one more time and let's put in those coordinates again. So it's 2, 7, 2, and negative 30. Nope. Really hard for me to type like this. Negative 13. And if I hit enter right now, now it should show me x equals 2, which is what I want to happen. There's one more thing that we're actually going to fix here. There's a lot of reasons why our current program isn't perfect, but we're just going to fix one of them. Let's run this one more time. So I'm going to go to program. Oh gosh. Hit enter, enter, and let's run this with 1, 3, 3, and 9. And we get something that looks like this. Y equals 3x plus 0, which is technically the correct line. But I'm guessing if you wrote this on a math test, your teacher would not be too happy with you because normally we don't like put the plus 0 in when we are kind of writing a line like this. So if you think about it, what is actually happening here? I'm going to reshare my screen because we're going to edit our code a little bit. What's happening is that I'm still calculating this y-intercept, but when the y-intercept is 0, I'm still displaying it, right? Because I'm always displaying it. Now, I think what I need to do here is add another if statement. If my y-intercept is 0, I think I actually don't want to have kind of this plus symbol and I be displayed. If it's not 0, then I do kind of want that to happen. Now, if we think about it, where is this actually going to go in my code? Well, it's not going to go in the vertical line case because that's kind of completely separate. So it's got to be somewhere in this else. And I think the issue is this display line. This is choosing kind of what's being displayed on my screen. So right before this, I'm going to add another if statement. Let's say if, and remember the issue here is that my y-intercept is 0. So I can just say if I equals 0, every if is followed by a then. Then what I want to display, and I can, the beauty of being on a computer is I can copy and paste this line. I don't want the I, and I don't want the plus. So it's just going to look like y equals 3x, which is exactly what I want. Now I can add another else. And remember, we have to add now one more end at the end since I added an if statement. So if you look at it, what I've added is an if statement that's inside of another if statement. We call this a nested if statement. This if statement will only happen if I end up in the else of this other if statement, which makes sense, right? This is the case where I have a vertical line. If I don't have a vertical line, then two things could be happening. I could have a line with a kind of non-zero y-intercept, or I could have a line with a 0 y-intercept. And I want to do two different things in those different cases. So now if I re-upload this onto my calculator, I can send this. Then I can run this again. So let's go program, hit enter, enter, and let's do 1, enter, 3, enter, 3, enter, and 9, enter. And now that plus 0 should be gone. Now our program's not perfect. Like if we put in a line that gave us kind of a slope of 1, it would say y equals like 1x plus 7 or something like that. Usually you wouldn't write that 1 either. That would need another if statement to fix. We only have so much time though, so we're not going to kind of go about fixing every single if statement that we've got. But hopefully this kind of gets you to a good point where you're able to kind of understand mostly why we need these if statements and how they work. That's kind of the big thing that I wanted to teach you as we're going through this project. So this was just kind of the in-class part. Now what we're going to do next class is you're going to start working on kind of a longer term project that you're going to get kind of one day in class fully to work on and then about a week to kind of work on, chip away at on your own. Let me talk about that project for a second. So I'm going to close out of this. I'm not going to save my program because I've got a billion versions of them, but you probably should. just because it's good to have. And I'm going to open up your project handout. So this is the project that you are going to be doing that you'll start next class, and it's to write a program called quads. So in the last program, what we were doing is we were doing kind of the equation of a line. Now you're going to be working with quadratics or parabolas. So we're going to be, instead of entering in 2 points, we're going to enter in kind of an A, B, and a C value for a quadratic. And your program has to do a couple of things. First, it has to display the equation in vertex form for the quadratic. It also has to give kind of correct x-intercepts. How do you solve for the x-intercepts? Hopefully, you said quadratic formula. There's going to be a little bit to do with graphing, which I'll actually show you how to do in your 2 points program in a second. And then you're not allowed to kind of have an error that happens. I'm going to go through this kind of more specifically at the beginning of next class. There's a whole section on kind of how to do the graphing. Um, and kind of how to test your code. I want to bring your attention though to this big rubric. You should actually know exactly what your score is going to be when you turn in this project. And that's because I actually give you a whole bunch of different values that you can test your code with and exactly kind of what should be output depending on what extra stuff you've added to your project. The things with the stars are the things you absolutely have to do. So you must have the equation in vertex form. You must have the x-intercepts, and you must have a graph. Um, if we go uh, if we go down here, you can see that there's more points that are testing more different things. There's a whole section on extensions. There's kind of the baseline project, and if you just do the things that have the stars in them, you kind of get a 45 out of 60, which is a mid-level C. But there's a whole bunch of extra stuff that you can add onto your project to get more points, all the way up to kind of 100% on this project. Technically, there's more than 60 points, but you're not going to get extra credit on this project for doing kind of more than 60 points worth of work, but you're more than welcome to if you want to. So this document is really dense. It tells you kind of a whole bunch of stuff, where to find things and all of that, um, and a little bit of help for kind of debugging and tips and tricks. So we'll go through this in more detail next class. Um, I realized I forgot to show you the graphing. So let me go ahead and kind of pull up my program one more time. Give me 1 second. So this was the code where we left it off. Um, I am going to add kind of one thing at the end that will allow us to draw. There's actually one really handy command that lets us draw a line for our program. And I can just type here, draw f, which stands for draw function. And then I can just type in the function. I don't even need any quotations. I don't even need any y equals. I can just type mx plus I. And this will actually just kind of work. Let me send this to my calculator. And I'm going to go ahead and run this. Oops, let me stop my share. And let's do the points that we just did. Let's do 1, 3, 3, and 9. And you'll see if I hit enter now, it's going to kind of quickly run through, and then it's going to end up graphing something. You can see I actually have other lines on my graph, which you don't necessarily want. What this program is going to do is it'll just kind of draw on the graph that you have. So if you have other lines kind of already in your y equals that are there, it'll kind of draw on top of them. Not the end of the world, but that's okay. But it'll actually kind of open up and draw the correct graph on here, which is really nice. You'll notice that it actually scrolled through my output really quickly. Let's actually add one more command to this. It's going to make it a little nicer. So before I do the draw F, I'm actually going to add a command called pause, which will make it so that I actually have to physically hit the enter button to do kind of the next part of my code. So now if I upload this back onto my calculator, can quit out of my graphing window. If I go to program and I run my program, let's do the same points, 1, 3, 3, and 9. You'll notice that it'll, oop, that's weird. Let's see, what did I do? Instead of grabbing pause from there, I'm going to try actually getting it from the program menu. So I'm going to do program control pause, and then I'm going to re-upload that. It looks like it is doing something weird when I type in the word for pause. So I just grabbed it from kind of the menu on the left side of TI Connect instead. It's in program control and it's about the seventh or eighth thing down. And let's run this again. So let's do program, see if this works this time. 1339. Will it work? So look, it kind of printed out my line and stopped, and I have to hit enter again. And when I hit enter, it'll kind of open up my graph. So this pause command is really useful when you're kind of printing out multiple things on the screen, or you want to print out something and then graph it. You don't want to just happen all at once. You want like a little bit of time in between. That can be super useful for you. So hopefully this was a pretty good overview of what you're going to be doing. There's also one kind of little homework assignment before next class, which is the pre-project handout, which doesn't have any coding in it, but is meant to kind of make sure that you feel pretty good about the math that's going to be in this project, which is really just math about quadratics. So this is what that looks like. There's a copy of it on Schoology. So you should be able to get it there. You can feel free to come find me if you want a paper copy of it instead. But this should really just help you kind of review the math. There is a question here about viewing windows, which I would definitely recommend reading through and kind of giving your best shot at because this is going to be part of your project as well. So I'm going to leave this here. Hopefully this was kind of useful and helpful. And hopefully you were able to follow along. It's okay if you weren't able to run it on your calculator, but if you weren't, it might be a good idea to kind of come see me before your next class. Thanks so much, and feel free to shoot me an email if you have any questions.